In this unit, we're going to focus on some of the fundamental aspects of identity management and specifically how identities are compromised. We'll take a look at the attack vectors and how Centrify uses the zero trust model to protect the infrastructure. We'll then take a brief look at the privileged access service architecture, its planning and installation considerations before breaking down the installation process. So let's start with the attack vectors. How we protect our identities is critical to protecting the network and the data that's stored in it. So let's take a moment to examine the risk factors of identity. And the two biggest risks to protecting identity are passwords and privilege. And the number one attack vector is compromised identities. Now, generally, compromised identities come about due to weak, stolen, and commonly used default passwords, shared accounts, and more importantly, shared accounts with privilege. As mentioned before, the more passwords we have, the higher the risk. Additionally, the more privilege a user identity has to the network resources elevates that risk as well. So let's take a look at this diagram. As you can see, the closer we come to the intersection point of passwords and privilege, the higher our risk. As threats are introduced, we want to make sure that our identities and our privilege are as far out as possible. The closer we get to the center, the worse we can become, and the higher the risk. The more password a user has, the more risk the organization has. And at the same time, the more privilege a user has, the higher the risk. What we want to try to avoid is the danger zone, where we have too many passwords and too much privilege. So when we start to look at calculating the identity risk value, we should consider all of these particular factors. We'll start with the actual users that are in your organization. These are the physical bodies. Compare that against the user objects that exist in your directory services environment. And in many cases, there are more user objects in directory services than you actually have in physical bodies. From there, we move into a group management perspective. How many group objects exist in directory services? And how many of these users have access to privileged account passwords such as administrator, root, or maybe an elevated sudo command option? The last area we should consider is much more specific. How many local accounts with privilege are on network resources? In many cases, local admin access should be restricted and confined to a directory service account, for example. But in some cases, local access is required, but it should be controlled. Now, attack vectors only scratch the surface of identifying your potential risk. We should also consider the attack surface. Now, traditionally, we focus our attention on the infrastructure, databases, and network devices, or what we consider legacy technologies. Legacy Privileged Access Management, or PAM, has been around for decades and has been constrained to systems and resources inside the network. System administrators access most servers with a shared administrator or root account that can be checked out of a password vault. And for years, legacy PAM served its purpose pretty well. The difference is today's environment has a new look and feel, and the attack surface is no longer confined to the boundaries of the physical data center. PAM must now extend outside the infrastructure, databases and network devices, and include cloud infrastructures or cloud environments, particularly when big data projects are a focus of the organization. Now, PAM must also include automation for DevOps instead of a single server, should cover hundreds of containers, and add this evolution to the legacy technologies, and it's pretty clear that legacy PAM is no longer the right option to protect the environment. Now, moving from legacy PAM to cloud-ready zero trust privilege takes into account the non-human requester, such as machines, services, and APIs. Shared accounts will still exist, but for increased assurance, individual identities can be applied with least privilege. Controls can be dynamic, and risk-aware, which requires modern machine learning and user behavior and analytics. Cloud-ready Zero Trust Privilege also integrates with a much broader ecosystem, such as infrastructure as a service, providers like AWS and Azure, and DevOps tools like HashiCorp and Ansible. These integrations and container solutions like Docker and CoreOS provide interoperability across the environment with the ability to grant least privilege and protect the environment effectively. So let's take a look at Centrify's Zero Trust Privilege model. Zero Trust Privilege requires granting least privilege access based on verifying who is requesting access, the context of the request, and the risk of the access environment. By implementing least privilege access, organizations minimize the attack surface, improve audit and compliance visibility, and reduce the risk, its complexity, and the cost of modern hybrid enterprise. Now, to achieve zero trust, organizations must discard, they need to throw away the old model of trust by verify, which relied on well-defined boundaries. Zero trust mandates a never trust, always verify, and enforce least privilege approach to privilege access from inside or outside the network. So if we break down zero trust privilege, we can break it down into these 6 areas. First starts the verification process, verifying the identity. And it's important to remember that identities are not just people. They can be workloads, they can be services, and they can be machines. So we need to get out of the thought process of identifying identities as individual people, because there are going to be instances where an identity may be a machine or a process. Next, we need to contextualize the request. Now, this is going to associate the request with a certain trouble ticket or workflow process and provide a reason as well as what is being requested and for how long. Now, once the request is contextualized, then it can be routed for approval. Now, again, the approval process could be something as simple as a verification that doesn't require human intervention, whereas others may have to go through a number of approvals where human intervention is required. But again, that all depends on the resource and the sensitivity of the data and the requirement for security of that data. Next, we need to have a secure administrative environment. When accessing privileged resources, it's critical that we don't either enable malware access to servers or introduce infections during our connection to those servers. But that's very difficult when we have a laptop or a desktop that we don't have control over, accessing the server directly. So to achieve this, we need to make sure that access is only achieved through a clean source. Now, Zero Trust Privilege means preventing direct access from the user's workstation that also has access to the internet and email, which are too easily infected with malware. What we do from a Zero Trust Privilege perspective is provide that secure administrative environment via browser or via verification through an agent. Next is granting least privilege. Least privilege means granting just enough privilege just in time, as well as limiting lateral movement. Just enough privilege to get a job done. Just in time privilege based on temporary access through a simple request process, and limiting lateral movement by only granting access to the targeted resources needed to get that job done. Next is we have to make sure that everything is audited. With a documented record of all actions performed, audit logs can be used for forensic analysis to find exactly the issue and to attribute actions to a specific user. These video recorded sessions are critical and should be securely stored so they can be reviewed or used as evidence in your most critical assets or highly regulated industries. There are multiple regulations, including PCI DSS, for payment card data that specifically require this level of auditing. The adaptive controls are really going to focus on the first 5 points that we just referenced. Adaptive control gives us the ability to learn as Zero Trust continues to evolve within the environment. For example, if a user uses their desktop in the office to connect to secured resources such as a server, then this is part of that learning process. We have verified the identity, contextualized the request, provided the secure environment, granted least privilege, and audited that information. But what happens if the user uses a different system outside of the infrastructure? The adaptive control gives us the ability to compare that information versus past information and apply policies accordingly. In some cases, that type of behavior wouldn't be allowed outside the infrastructure, or it may require further verification or a further contextualized request in the form of workflow. Even though the user had been granted access before, the behavior has changed, and as such, further verification and approvals are needed. Now, Centrify's Zero Trust Privilege model focuses on three critical areas: the discover and vault, identity consolidation with least access and privilege, and hardening the environment with high assurance. Now, we're going to cover all of these in this course, and it's important to understand how these solutions are going to apply to these three main areas. Privilege Access Service, the first portion of this course, is going to focus on discovery and vault, being able to vault and manage shared, alternate admin, and local admin accounts as well as secrets. Authentication Service and Privilege Elevation Service will focus primarily on identity consolidation and least access and privilege, where we can establish alternate admin accounts, just enough privilege through roles and elevation, and just-in-time access through workflow. The hardening of the environment with high assurance is going to focus around the centralized management of service and application accounts, the enforcement of host-based session, file, and process auditing with integration with a SIEM, as well as enforcing MFA or multi-factor authentication at the NIST Assurance Level 3. So let's break down Centrify's privilege access architecture. It's going to start with Shared Account Password Vault or Shared Account Password Management. This is where we can vault secrets, domain accounts, local accounts, and database accounts. This will include the local root, administrator, or service accounts, as well as SSH keys and AWS access keys. This is controlled through a password checkout process and through establishing sessions without disclosing passwords. The vaulting process creates a complex, high-entropy password that is very difficult to crack, with real-time discovery and vaulting of accounts, and the enforcement of MFA or multi-factor authentication on vault login, checkout, or session initiation. Secure Remote Access grants targeted access to servers and network devices, enabling access to the infrastructure through the browser or local clients such as PuTTY or RDC. This feature is ideal for remote administration by third parties and outsourced IT, where we can establish privileged sessions with individuals or shared accounts with a single access point to on-prem or cloud infrastructure with built-in risk-aware MFA. Access request and approval workflow focuses on just-in-time privilege access requests, enabling controlled, incident-based access and privilege with multi-level workflow-based approvals. This governs access to host-enforced roles to grant individuals access and privilege, requiring multi-level approvals such as access roles and privilege roles, and compliance reporting. Session recording and monitoring detects suspicious user activity alerted in real time. Session monitoring eliminates anonymous activity, providing shell and process level monitoring in addition to monitoring changes to critical files and directories. Now, session monitoring gives us the ability to detect some of the common activities that we see, such as backdoor accounts, malicious activity through aliases, and spoofing. When Privileged Access Service is implemented with Centrify's Zero Trust Privilege Enterprise Edition, high-fidelity recording of privileged sessions can be stored and reviewed. Privilege elevation activity can also be captured, and alerts can be transferred to a SIEM for high-risk activities. Now that we have a better understanding of the architecture and the Zero Trust model, let's start taking a look at the planning process for implementing the Vault or Privileged Access Service. This is going to start with the number of devices that you plan to manage, as well as the number of identities that you're going to be managing. Time and staffing will always be a part of that deployment plan from the standpoint of technical support, but also user rollout. Process considerations such as change orders have to also be included in the time factor, as well as user interruption considerations, training, and support specifically. Now, once these items have been considered, examining the installation process and identifying the components you plan to install is a reasonable next step. In your student guide, we've added a short checklist you should review prior to your installation of Privileged Access Service. These items are consistent with the Centrify Professional Services engagement deliverables. Now that you have your preliminary plan in place, it's now time to extend it. And it's going to start with the pre-installation process and identifying specific individuals as well as resources that are going to be needed for the full implementation. And it's going to start with your organization's technical expert. This will be the individual with the appropriate Active Directory or directory services permissions available for the installation process. We'll next need to identify the team members assigned to manage and support the solution. It's important once we have the team, we need to make sure that they're trained. So technical training is also going to be an important aspect. We talked about change orders previously. Change control submissions and approvals that are required for the installation and configuration of the solution should be submitted. Next, we move into the more technical nuts and bolts portion of the solution in terms of what type of installation are we going to perform. This will be discussed in the next chapter. We'll also need to identify those systems that are going to be used for the installation. And we'll need to identify the systems, shared accounts, and applications that are going to be managed by this solution. Another step is to make sure that we identify the team roles and policies for privileged access. Not all teams are going to have administrative controls or administrative privileges. So we need to identify those teams and identify what privilege they should have. Now our plan is taking shape and it's time for the installation. This will start with the organizational communication and in-house training, followed by the in-house testing, which will be done not just with the technical teams and support, but the selective team participation in terms of departmental use of the product. Once the implementation is underway, we can now consider the post-installation processes, the configuration adjustments, the overall team rollout for your organization, as well as additional support action items that will take place between your organization and Centrify. This may include break-fix related support issues, educational how-tos, and feature requests. Now let's take a look at the Centrify licensing options. When we license Centrify solutions, this is going to be based on the number of systems in the environment that are going to be managed. Licensing costs will be determined based on the device types in the environment, and they can be purchased individually for the following core components: Privileged Access Service, Authentication Service, Privilege Elevation Service, and Auditing and Monitoring Service. Licensing can also be obtained as part of a suite or bundle, such as Zero Trust Privilege Core Edition, which includes Privileged Access Service, Zero Trust Privilege Standard Edition, which includes Privileged Access Service, Authentication Service, and Privilege Elevation Service, and the Enterprise Edition of Zero Trust Privilege, which includes all 4 of the core components.